So our list is getting shorter and shorter on the technology that we need to cover in our laboratory. And the next one is something called a titrator. Okay, so in the wet chemistry field, the process of titration, people either love it or they absolutely hate it. They despise it. They hate doing them. And this is the setup. So we typically have a burette, and the burette has a stopcock here at the very bottom that I would turn off and on, and that would drip solution down into a beaker or a container that sits down below. Inside of this burette, I would have what we would call a titrant. And I'm going to say that our titrant in this example is going to be sodium hydroxide. All right? Well, this sodium hydroxide has a known concentration. I know how strong it is. I probably made it. I put it into the burette, and it's going to be my job to figure out how much volume it takes to titrate the sample down at the very bottom. Well, this sample has an unknown concentration of something that I'm looking for. Well, if I'm using a base up here in the burette, I'm probably going to be titrating that with some type of acid. Who knows what it is? Let's say that I'm titrating a sample of vinegar. So I take some White House vinegar, I bring it into the lab, and I begin to titrate it. Well, vinegar is an acid. Therefore, I need something to react with it, and that's going to be sodium hydroxide. All right, well, it's my job to figure out what the unknown concentration is through the process of titration. So what typically happens is that I put my sample of vinegar down here at the very bottom. I add some indicator to it. An indicator is going to be something visual that I will be able to see so I know when to stop adding my sodium hydroxide. So what happens is that drip by drip by drip by drip goes into the sample. A reaction is going on. And there's going to be a certain point where the acid, the vinegar in this case, is no longer present. I've used it all up. There's no more acid to react with. And when that happens, the next little drip of sodium hydroxide would make this solution maybe turn pink, if that's the indicator that I've used. And I stop the titration at that point. Well, I'll do a little bit of math. We're not going to go through that math right now. That's something for a different class on a different day. But I would go through some math to report the concentration of the sample that I have titrated. This is a very physical process. I have to be involved with it from the very get-go until it stops. And typically what happens is that we would at least do 3 of these per sample, meaning that 1 shot's not good enough. 2 shots is lucky. 3, you can do at least an average. Okay, so I would titrate 3 times per sample. What if there were 20 samples that were given to the lab? 20 samples times 3, that's 60 titrations. I'd be there all day. So that's one of the problems. It's the time commitment. We could actually maybe hire someone to just do titrations all day long. That's all that they'll do. I don't know how long they'll stay at their job, but some people love it. Some people would prefer to do this. Well, there's hundreds of different titrations that are out there. This is just one example, people, right? It's a traditional acid and a traditional base that's reacting together. We can calculate concentrations of something. Well, there's tons of different ones. So, for example, if you're in our 114 course, our wet chemistry lab, we'll go through a series of titrations, but one of those titrations is going to be a nicotine lab. You're going to be titrating nicotine to get a nicotine level in vape juice. Okay, so I started this whole module off basically saying that the whole purpose of technology is to make our life easier in a laboratory. I would like technology to take over. I would love technology to take over this titration process, especially if I have to titrate 60 samples. That way I can go do other stuff that I need to do and not worry about this. And that's the purpose of an automated titrator. Okay? So an automated titrator, we landed about $15,000 on this instrument. It's a very basic titrator. It does basic titrations for us, and that's it. There's no bells or whistles on it. If I did want bells and whistles, this thing would crank up the dollars very quickly. It will go $20,000, $25,000, $30,000, $35,000 a piece, depending on what I need. Basic titration though, 15 grand, slap it on the table. I've got a titrator now. Okay, so the manufacturer of our titrator, the thing that will, or the company that will do this automatically for us, we've kind of already seen at this point. And this is Metrome. We're going to go back to Metrome. These are the people that did our ion chromatography system. All right. Well, they have also a line of titrators. So I'm going to go into products, and over here to the side, I'm going to see a couple of different listings, and one of those up here at the very top is titration. They are widely known for their titrators. Okay, Metrome almost saturates the market with titrators, and Metrome almost is getting to the point where they have the majority in ion chromatography as well. So if I click the titration section, this will pull up maybe an image or a video here, at least on the website, that is a little bit about titration as a whole. So down here at the bottom is what a titrando looks like. They call it a titrando. Other people call it a titrator. Doesn't really matter. But if I click on the titrando, I'm going to see different options that I can do to make this thing work for me. Number one is it can be standalone. I don't need to hook it up to a computer or a software platform. Everything can be controlled from the standalone device down here that this girl is using. And it can then be relayed to maybe a network printer or something to save or print my reports off with. Or you can hook it up to a computer and software. That's okay too. Notice you can also hook up a auto sampler to this. Here you'll see the bottom end of an auto sampler. You'll see kind of beakers that are used. It doesn't hold a lot, not like some of the other auto samplers that we have, but it does hold quite a bit of them. And it begins to titrate the samples one after another after another. The thing needs pH probes in order to work. That's how it does its job. So that way it doesn't need an indicator. That way it knows when to stop the titration because it kind of figures, well, when is that over? And there's different kind of options that I can add to this titrator to make it more convenient and more relevant to what I need to do in my own laboratory. All right, so it says Titrando titrators have been developed to basically, if I can get rid of that, to meet exacting titration demands. These titrators come with a wide range of security and traceability options, making them particularly suitable for use in regulated industries. Titrandos are capable of performing all common titration types and offer a host of automation and control options. TMO is going to be the software platform that the titrator uses. And again, I can modify and customize it the way that I see fit. Also note that they brag about their full traceability and compliance, both in FDA 21 CFR Part 11, GLP, and GMP. All right, if I click all Titrando models, a web page will show up. It will kind of give me an idea of what else is out there as far as the Titrando goes. Our model is 808. So our model was ordered over 10 years ago. It still works fine though. It still looks basically like this 904. There's no difference in it at all, except they've made a few engineering changes that made better sense. Again, we'll talk about this in our instrumentation classes or when the first time that you use the Titrando and be introduced to titrations, but this is kind of what it looks like and this is its purpose. So if you hate titrations, good news. This has stepped into play. If you love titrations, good news, you can still do them. It's just more automated now. You can still stand there and watch the titrations take place, but it can provide you much more data than what you could have gotten just from a hand titration itself. All right. Okay, so that's the story with the titrator or titrando, an automated titrator that's basically a burette that adds titrant to a sample, and the whole purpose is to calculate a concentration of the sample that's been submitted to the laboratory. Another thing that I would like to mention is our MP50 system. The MP stands for melting point. And this is an automated melting point system. Not a lot of people use these, right? But again, I have to rely on subjectivity. I get you to go in and do a melting point. I get 3 other people to go in and do a melting point on the same substance. And there's a chance that all 3 or 4 of you will come back with a slightly different number. So I have to make sure that we're staying consistent. I have to make sure that it's the same number over and over and over. And instrumentation is a great way to incorporate that concept. So we have a melting point 50. So basically what happens here is that we have a box. And inside of this box, we have a laser beam. All right, so I've got some samples that maybe will stick into the melting point system. And there's going to be a laser beam pointed at each one of these sample capillary tubes. Think of them as small little test tubes that you can barely put something in. Well, these things go down into the melting point system. They're holding some solid. And there's a black dot down here at the very bottom of each one of those sample compartments. That's where a laser is going into the picture. All right. So if you have a solid, and I'm going to enlarge this up a little bit. Let's say that I've got a solid that's packed down here at the very bottom. And I've got a laser that's trying to go through that capillary. Well, if it's a solid, that laser's never going to make it through that capillary chamber, right? The solid is going to completely block it. Well, this melting point system, the way that it works is that it slowly will heat up the bottom end of this capillary where your sample's at. And as it gets hotter and hotter and hotter, what you will find is that this solution or this solid will slowly begin to melt. And as it slowly begins to melt, it will turn into a liquid. And when it does turn into a liquid, at that point, the laser can then go through the capillary and out on the other side. And there's a detector that's over here that's waiting for that signal. So when the laser is able to make it through, the detector triggers that signal and says, okay, we found the melting point. So the melting point is of course, the temperature at which a substance changes from a solid to a liquid, and that melting point will be reported in terms of degrees Celsius. So we can say, hey, it did it at 125 degrees Celsius, and we can take that number now and compare it to the expected value of that sample that was brought in to the lab. So that's how the melting point system works. So who's our melting point system provider? So here's the website that's our manufacturer for our melting point system, and it's Mettler Toledo. So I want you to go and I want you to maybe go to Walmart the next time you're there. Take a look at the deli counter. They'll probably have a scale that they are using to weigh out maybe the fresh sliced meat or cheese if you purchase things from that area. And it's probably a Mettler Toledo scale. They are widely known in industry for their balances and their weighing capabilities. That's kind of how they got started. But again, like all the other companies, they venture off into other things as well. So one of these, if I click under products, I'm going to see a lot of different things through here, right? I mean, even down to pipettes, manual pipettes, electronic pipettes, pipette tips. I mean, they are really kind of breaking out into a lot of what we would just generalize as the wet chemistry area of the sciences. But there is a thing of analytical instruments. Notice they do some UV vis spectrometers. They have a density meter of their own. They have titrators of their own. They also do pH meters. Typically, those go hand in hand. But one of these is a melting point and dropping point. So I'm going to do melting point excellence. So we're going to click that. And here's a picture of our melting point system. There's two different versions of these. One holds 4 samples. One will hold 6. We have the model that holds 4, so we did not spend the extra money to go to the 6 chamber. 4 chambers are okay with us. But it gives you kind of a rundown of all of the things that you can do with the melting point system. Notice here, these are the capillary tubes right there. So this is a specialized holder that will kind of hold all of them up in a row, so that way you can maybe pack all of them at one time and you don't have to do them one by one by one. So it just kind of helps increase the productivity of the lab a little bit. That's all that capillary tube holder is for. But here is a screenshot of the actual instrument. And notice that there is basically an electronic view, a magnified electronic view of the capillaries as you put them into the machine. And here we can clearly see the solid that's down at the bottom of each one of those capillary tubes. So you can actually watch the samples melt over a course of time, and the machine will record that video feed for you. And you can go back and you can replay that video feed and re-watch it at any point in time. So our machine will remember the last 10 runs. It runs out of memory after that, and then it moves on. It deletes the old one, stores the new one. But you can also put SD cards on the inside if you want it to. You can get fancy with this. You can hook it up to a computer, hook it up to some software, allow it to record data, whatever the case is. You're going to be able to find that with the Mettler Toledo. We just basically have it as a standalone instrument. We don't have it even hooked up to a printer. No computer, no software. We just do the melting point and we write down the melting point and we call it a day. That's all that we've done with that system itself. So this system, a couple of different options. Ours is the MP50. Notice MP50 is not even listed anymore as an option for you to purchase. There are newer, upgraded models all the way through. If you take a look at these, it will tell you kind of the temperatures at where they cap out. So it gives you an idea of the hottest temperature that you can get to. But that's one of the differences between the different models. So we landed about $8,000, I believe, at the time for this melting point system. It's something that we use all the time in the lab. We use it to help identify products that we're making in the laboratory or samples that are submitted to the laboratory for analysis. As far as the documentation goes, again, you can click on that link. It will give you some applications, like why are they using it. Here's the melting point of urea, melting range of rubber chemicals, dropping point of what they call lubricating grease. I mean, there's all kinds of different things that you can do with the melting point system, but we basically use it as a physical property identifier, and that's about it. Here's the LabX software. This is the software platform that they use, and they've made it universal. So not only does it work with your melting point system, but it also works with your balances and anything else that's Mettler Toledo. So it's a universal software system that is suitable for anything that you purchase for them for the most part. All right, so that's the melting point system that you're going to find. One last instrument that I would like to talk about here. And this is something that you will eventually use probably in our forensics class, and that is a PCR instrument. So polymerase chain reaction. And this is mainly due to DNA studies, and that's why we would use a PCR. But what happens with a PCR is that we have this box, and this box has a lid, and that lid will open up, and on the inside of this chamber will be areas that I can put very small microcentrifuge tubes in. Okay, and the purpose of the PCR is to basically equilibrate the samples. It will heat the samples up, and then it will allow the samples to cool down, and then it repeats the process all over again. Okay, so we'll eventually talk more details about the PCR and how we even get a sample to this point in the beginning, but that's the purpose of the PCR, or what we would call the thermocycler. Now you know why it's called the thermocycler, because we are playing around with temperatures. We're heating it up, we're cooling it down, we're heating it up, we're cooling it down, we're heating it up, we're cooling it down, and it typically will do this 30 or more times. Okay, each one of these stages, we hold it for a couple of minutes before it goes on to the next step. So you can imagine this process would take all day or maybe overnight, and things would be ready the next morning for us. What happens is that it takes a very small sample of DNA and it will amplify it. So it will give me more and more and more and more of it. DNA at its nature loves to replicate itself. And what happens is that the DNA will, no matter how small of a sample that you have, will typically like to unzipper, like a pant zipper or a jacket zipper. It unzips itself, and then it will replicate itself and spawn new DNA babies. That's basically what happens, right? And then this one little DNA strand could separate into two strands and make copies of itself. And those two would make copies of itself, and now we have 4. And those would make copies of itself, and now we have 8. And then those would make copies of itself, and we have 16. And then we have 32, and then we have 64. You can kind of see how we amplify the amount of DNA very quickly using this process, but it takes a cycle in order to do it. So we heat it up, we cool it down, we heat it up, we cool it down, we heat it up, we cool it down, and we do it over and over and over. And that PCR thermoanalyzer will do all of that for me automatically. No longer do I have to wait in the lab, and no longer do I have to go in and heat these things up and cool them down to temp and hold them there at that temperature for however amount of time it needs to do. The thermocycler, I'm not going to show you basically the instrumentation manufacturer. I'm not going to get into that type of detail yet. Again, we'll wait into our forensic course in order to talk about that, but that is the purpose of the PCR analyzer that we have. Okay. In addition to that, we also have what we would call electrophoresis chambers. And the electrophoresis takes something like DNA and it begins to separate it. I mean, it seems like that's the word that we've always seen, separate, right? So the electrophoresis chamber will separate DNA into what we would call the DNA ladders. So I'm going to pull up an electrophoresis chamber just so you can kind of get an idea of what one would look like. And here we go. Any one of these are okay to pick from. Here it looks like this one maybe is a little bit labeled, but the picture's not that good. I can't really enlarge it that well. So here's an electrophoresis chamber. What would happen is that I would have this jelly-like substance down into this chamber, and there's a couple of wells up here at the top that would hold my DNA sample. And that's what you're seeing down here at the bottom. Okay, these are kind of molds or templates that I would pour my like jelly-like substance down into and let it kind of jello out, and it'll jiggle like jello, but it will hold my DNA sample. And I put one of these into the chamber, and a black and a red cord basically means there's charges that are associated with that chamber. So those charges play off of the charges of the DNA, and I begin to band out the DNA strands itself. And here I see a picture of one that's actually starting to separate on me, okay? So a DNA strand or some type of coloring agent's probably added in here, and I can visually see those colors getting separated, and it does, and it treats the DNA strands the same way. So everyone's DNA strand is a little bit different. Everyone's will separate out in a different way. Here you see the actual wells that will hold the DNA sample itself, and it will start to band out as long as I've got the right kind of dye or the right indicator that I need for the actual process itself. What do I end up with after this? Well, it's something called a DNA ladder. And a DNA ladder is this typical image that you would always see. So these are coming from electrophoresis chambers, okay? So here I see different ladders and different areas that maybe some banding could take place, and it gives me an idea of the size of the fragment that's associated with this location. So again, my DNA will break up in a different fashion than yours, and my DNA could go into the electrophoresis, your DNA could go into the electrophoresis, and we would see different banding that could happen. So for instance, here maybe would be my sample, over here would be your sample, and notice how none of these are really matching up, right? So this is how we kind of determine in a way who's the baby's daddy. This kind of process is very commonly done in the forensics world because we do a lot of things with DNA. So this is just a start, though. It's just an overview. There's so many different things that we can do with electrophoresis and, quite honestly, DNA, that this just really scratches the surface, and that's about it. So these banding or DNA ladders come from the electrophoresis chambers, and that requires DNA sample that you might had to have put into a PCR before you got it to this position, right? Especially if you don't have a lot of DNA to work with in the very beginning. So, with that said, I think we are finished with equipment. So go through, take a look at these videos, and good luck on the assessments.